there. That's how you know if it's a hyperbola, is right there by the minus. Okay, hopefully you've seen that in class. Hopefully, instructors made that clear. Just like ellipses, there's two types of axes. There's vertical and transverse. So a couple other little like tidbits here that could be useful. Notice that the variable that's in front dictates whether it's horizontal or transverse. So in your problem here, you've got x minus 5 in front of the negative, so it's a horizontal. That's how you decide. You've also got a little different ABC situation down here, okay? In the ellipses, it was a squared equals b squared plus c squared. Now it's a new equation, kind of rough. So in this problem here, your A is always under the first one, and your B is always under the second one. So you're always kind of like looking for things to help you minimize how much you have to remember when you do this. So just like the previous problems, you got to find H, K, A, B, and C. So in this problem, H and K are 5. Okay, notice it's H is always associated with X, K is always associated with Y. And then A, B, and C, as mentioned previously, A is always in front of the first one. 196 square root is 14. Square root of 4 is 4. And then C, you have to know this relationship. That's the Pythagorean theorem. Anything I'm saying sound foreign to you or unlike what you've seen in class?
No, it's pretty much the same thing.
Yeah. So this is the square root of 200, which is 10 root 2. Do you need any reminder on how to reduce roots?
Probably.
Okay,
it's been a while.
Let's do that here. So you always start with the first prime number, which is 2. Just writing a few out here in case you want to look back later. 2 and 100, you try 2 again. 2 and 50, try 2 again. 2 doesn't work, but 5 does. 5 and 5. You circle pairs. So you bring a 2 out, you bring a 5 out, and you bring a 2 in. So it's 2 times 5 on the outside, square root of 2 on the inside. That's why it's 10 root 2. That's where the 10 comes from. There is kind of an alternative approach. I mean, if you're kind of a more advanced math student and you kind of see, okay, like that's nice, maybe I should have known that. It comes from right here. Whenever you see a perfect square, you can actually stop, but it doesn't always work. So I mean, meaning like it doesn't always happen. So I don't want you to always be like, oh, I'm going to look for the perfect square. That works less times than the way we've done it here. Okay, so the big deal here is finding all these variables, right? A, H, K, A, B, and C. So I'm just going to kind of reset here, putting those down. And the graph here, you got a graph, I think. I guess they didn't. What are the instructions for 3? Do you need a graph, or is that coming up on 5?
It just says identify the vertices and foci.
All right. So we're going to go back to that equation sheet. You're going down the right side here of it. So your center is HK, which is 5, 5. Your vertices are H plus minus A, comma K. So that's 5 plus minus 14, comma 5. We'd want to convert those to 2 ordered pairs. So it's 19, comma 5, and then minus 9, comma 5. And then the foci, H plus minus C, comma K. This one you can't get much out of because it's 10 root 2. There's your foci. I know you don't need to graph this one, but I think it's worth snipping in a quick graph of this thing, just to see it. So let me do that here. Minus. All right, now this this business of horizontal versus vertical axis, it tells you, because there's actually a ton of symmetries. You can't just like say, oh, it means it's horizontal. Kind of tells you the way that it opens is the way I like to think of it. It opens horizontally. I'm sorry, maybe that doesn't make sense. I don't know. You got to kind of, I think of vertical is up, down. So horizontal is left, right. I don't know if that will help, but that's something that I've used over the years to think about these. Any questions before we move on to another one?
No, it's pretty easy.
Yeah. Yeah. Do you have a quiz coming up?
I just have a test on Tuesday.
So nothing tomorrow. That's good. Is the test
You-
covering, sorry?
The test is supposed to be tomorrow, but I guess you decided that that'd be too evil because you gave us a quiz the past 3 weeks.
Yeah. It's the test here. I mean, the challenge on the test is you got to know all of them, and he's going to mix them up, or maybe you know, have a few of one but more of another. It's just tough, really tough. So again, our goal is to identify H, K, A, B, and C. H always goes with X, K always goes with Y. Can you give me the values of H and K here?
Hang on, let me write this down.
Sure.
So for this one, would we use the horizontal major axis?
No, this one is okay. But so H and K have nothing to do with the like which path of the equation you're going down. I just want to point that out again because there's a way to overcomplicate this, and that's kind of what I'm hearing. Whether you're looking at the one on the right or the one on the left, H always goes with X, K always goes with Y. But to answer your question, be more direct here. The letter in front of the negative tells you which one it is. In fact, you know, Y is vertical and X is horizontal. That's another way to look at it. So this one is a vertical transverse axis, meaning it has the top and bottom shape.
Okay, so the H would be see the original. The H would be 1, and then the Y would be 0.
Okay, H is not 1. Let's go back and look at the previous problem. H is 5.
Oh, yeah, it's the inverse.
Yes. And I don't know how you got to remember that. Like you're going to see that again next year in your math class, regardless of what you're taking. You're going to see something like that. Notice that no matter which equation you're given, whether it's vertical or horizontal, A is always under the first one. If you're calling ellipses, it flipped. It was different depending on, you got to look for things that are the same in, you know, these ones. So A is always under the first one. A is 5, B is 2. C, this comes from the Pythagorean theorem here. So you take A, square it, B, square it. You basically are adding up those numbers and take the square root of it. Any questions on before we go to graph it?
So just to be clear, the H always goes with the X and the K always goes with the Y.
Always, even in ellipses, even in parabolas, circles, always with it.
Okay.
Got it?
Yeah.
All right. So the next thing here, and I like to graph as I go. So I'm going to grab the graph from the email here. Did you guys talk about a box method?
I don't think so.
Okay. All right. So the graph starts with the center -1, 0. I guess I do it in red so you can see it. There it is. The next thing is to graph the vertices. Okay, so you got to go. You're in this part here. So your vertices are at. Let me write that vertices -1 comma k plus minus a. So 0 plus minus 5. So that's -1 5 -1 minus 5. All right, like that. The foci always go inside the thing here. We will graph those, but the asymptotic equations are actually the next thing to graph because they're going to create boundaries for the hyperbolas, the parabolas. So we're going to do that next. The asymptotic equation y equals 0 plus minus 5 over 2 x minus a -1. So I'm using this asymptotic equation here, putting the values in for that. So this is 5/2 x plus 1. The thing that's probably made overly complicated by this equation is that you actually just start at the center and you use this as the slope. So 5 and 2, up 5 over 2, down 5 over 2. So you get this kind of this dashed line here. And then by symmetry, you go the other direction. So you basically mirror it going the other way. So you go in the opposite direction down. Oops, get that one down here. That right there. And then there, and you build this other asymptotic equation. That's the -5 over 2. So one's positive, one's negative. So the positive one's kind of the one you're used to, and then the negative one, you just go the other direction. And what this does is it makes this nice boundary for the hyperbola. And I mentioned a box earlier. This is what I was referring to with a box. Anything you'd like me to clarify or explain more on that one?
I've never seen that before, but it's actually pretty good strategy. Is that the way you're supposed to do it?
I mean, depends. I mean, I only, the bigger overarching question is like, why do you need to graph this when there's a calculator that can do it for you, right? But like it helps because the corners are where the asymptotic equations go through, and they create that boundary for the hyperbola, and it works horizontally and vertically. Okay, so the last thing is the foci. Foci, if you recall, they're the same distance. So, okay, let's the square root of 29 is between 5 and 6. roughly. So you got to kind of know where that is. You're taking your K value, which is 0, and you're adding plus or minus square root of 29. So your foci, I guess I'll show that maybe a different color, blue. Foci are kind of like here and here inside the, but they're always inside the parabola. Hyperbola is 2 parabolas.
So if it asked me what the foci was, would I just say the foci is -5 and then 0 plus minus square root of 29?
So it's, yeah, it's, we'll be more explicit here. It's H plus minus, sorry, H comma K. So it's, in your problem, it's -1 comma plus minus the square root of 29. So the one up here is -1 comma square root of 29, -1 minus square root of 29. All right, any questions on before we move on to number 6?
No, not yet.
6 is another vertical transverse. Do you want us to go to 7, which is a horizontal transverse graphing? Or do you want us to do them in order?
We can go on the 7.
Okay. All right, number 7, rinse and repeat here. You got to find H, K, A, B, and C. Your H is always associated with X. Your K is always associated with Y. Those are both 0. Usually if they ease up on you on H and K, the A, B, and C are a little bit more of a hassle, as is the case here. They just aren't doing you any favors here. So A is the square root of 10. A is always under the first one. B is the square root of 20, which does reduce. We'll come off to the side and do that. 2 and 10, 2 and 5, 2 square root 5 for that one. C, you take the two numbers, the original numbers, add them together. That's 30. Square root of 30 does not reduce. The anything clarify there?
Yeah, just I don't really know where you'd go from here.
You got to decide which one it is. And I mean, you can do that from the beginning, but I like to get the values to kind of tell. So is it the vertical or the transverse? The big difference is what comes before the subtraction.
Oh, it'd be horizontal.
Yes. So that's the next thing. Now, in terms of your graphing, what are you going to do first to graph? You graph the center and then the asymptotic equations or asymptote equation. Then I'm sorry, I should say it differently. That's 3 center, vertices, asymptotic equation, then the foci. it's probably a good idea to like approximate like what A is and what B is. A is approximately 3, B is approximately 5.5, B is approximately 4.5. You can use a calculator if you're really unsure, but for example, square root of 30. Square root of 30 is between the square root of 25, which is 5, and the square root of 36, which is 6. So it's somewhere in the middle. All right, so let's graph this. We'll start with the center. Get that snip in of the graph. All right, so we're gonna do a little bit of scrolling here. The center is at HK, which is 0, 0. Next is the vertices. So the vertices are at H plus minus A comma K. So for you, that's 0 plus minus, and then your A value is square root of 10. So plus minus square root of 10 comma 0, square root of 10 comma 0, minus square root of 10 comma 0. So that's roughly a little bit bigger than 3, a negative 3. So roughly there and there. Then the asymptotic equation. Now, you could get really caught up in writing it. You actually just need the slope. The slope is used from the center. The slope is B over A. B is 4.5, A is 3. So that asymptotic equation, B over A, 4.5 over 3, it's about 1.5 or 3 halves. And that tells you, plus minus, that tells you from that center how to proceed. Think of this as the slope. So think of it as positive 3 halves and then minus 3 halves. So up 3, right 2, up 3, right 2. You know, close enough. We don't have to be, you know, we're not a computer, close enough. Then you go the other direction, minus 3, 2. So down 3, right 2, down 3, right 2. And you get your other one. This is where I draw the curves, kind of right here between 3 and 4 as you draw the curves. So it's something like this, something like this. And then last thing is that foci. The foci is H comma K plus minus C. No, grabbed the wrong equation. H plus minus C comma K. So your C value was the square root of 30. So that means you're going, you know, 5.5-ish. There. And there's your foci. Foci are always in line with the center and the vertex, just like in ellipses.
So for the asymptote equation, does it you always have to do the entire equation, or do you just do the A and B?
So if you start at the center, think about what that means. H and K is the center. That's why they're in the equation. It's actually point slope form. So when you start at the center, you can just look at the B over A always.
Oh, okay.
Like in the last problem, we were kind of, well, that's not a good example, but in other problems where you're off center, you just go to that center point and graph from there. You don't have to, because what you end up doing is going to the center anyway. and it's overly complicated. So yeah, just wherever that center is, you create those lines. Okay. We're moving on to new problem here. So these are going backwards. I guess we're starting with 13.
Yeah.
All right. So this is some new language for me, conjugate axis. I'll have to look that up. I haven't seen that in a while. The game, when you go backwards, is to figure out HK, A, B, and C. When we do that, we know we are done. The foci here tell you something. They tell you that it's 0, 6. We'll just make a quick sketch, and 0, -24. So that tells you, since the foci line up and down, that it's a vertical axis. And that tells you, okay, I know which equation I'm using now. I'm using the one on the left, the one for vertical. If you don't know that, you'll go down the wrong path pretty quickly. So we're using the stuff on the left here. So the foci equations are H, comma, K plus minus C. So in your problem, they're telling you that K plus C is 6 and K minus C is -24. We know the value of H. H is the same in both. H is 0. So to find K and C, you have to add the equations together and divide by 2 here. So K is -9. To find C, you go back and use one of the equations. So K plus C, which is -9, sorry, -9 plus C equals 6. And then you solve for C, C is 15. Any questions on that? Is that
So -9 plus C. So the K plus the C equals to 6. Oh, well, okay, yeah, that makes sense. I got it now.
okay? The thing is that is different than maybe the last time we did a lesson with ellipses is like we got an A and a B or an A and a C, I can't remember, but we could quickly find the other one. Here we don't have enough. We have to use this thing called the conjugate axis. And I have no idea what that is referring to. It's probably the distance between vertices, but I need to check because this isn't standard language. It's rare to actually do any more. Conjugate axis, distance between the co-vertices. We don't want that. Do you have any notes on this? I'm just looking for a quick formula.
No, but he uses them in like all of these questions.
Yeah, I see that. It's a kind of reckless here. So the conjugate axis is the, I don't want to explain this. I don't even know how we're going to use this. Well, I can't just get a formula for it. They just keep telling me what it is, and I know what it is. I was hoping there was just a, here's the, okay. Great. Here's the good news. I do have the answer for it. The conjugate axis is 2b. This distance right here is 2 times b. So it works for both x and y. Just double checking here. There it is. Yeah, okay. Is it okay if we go with that, or do you want more explanation on why it is 2b?
That's fine.
Okay. So what that tells you is that b is the square root of 95 in this problem. And that's enough to find a. If you have two of them, b and c, you can find a. All right, so we're gonna use the a squared plus b squared equals c squared. A squared plus the square root of 95 squared equals 15 squared. A squared plus 95 equals 225. And then when you subtract here, you get a squared equals 130. And I think that's sufficient.
It's around 11.5.
Yeah. So I think the whole thing here was to write the equation. Is that what it says? Use the information provided to write the equation?
Yeah, in standard form.
Standard form. So that's where you got to know, is it the one on the left or the one on the right? We now know it's the one on the left. We talked about that for a while. Once you've got the 5 values, you really only need A and B, but they're going to give you C to find the other one. You're just substituting in here. So y minus a minus 9 squared over the square root of 130 squared minus x minus 0 squared over the square root of 95 squared equals 1. With just a small simplifying here to kind of make it look nice. And what we could do is we could graph this and verify that all those points are on there. If you wanted, that would be another thing to think about doing here.
Can I enter that into a calculator?
You ever use Desmos Scientific? Or I'm sorry, Desmos
Yeah.
calculator? Yeah, and
I
that's,
know it works on Desmos, but I don't think it can work on a graphic calculator.
it does not. Yeah. So it unfortunately, the only way to graph this is to graph the top half and then the bottom half. To graph the top half, you have to solve for y, which is fraught with errors. And then in y1, you put the positive, and y2, you put the negative, and then you can get a graph of it. Do you want to try that, or do you want me to show you where to go to graph it?
It's fine. I was just wondering. So I tried to check my answers in the last test, but I noticed because of how the whole equation equals 1, you can't graph it.
Yeah, you literally have to move stuff around This one, I mean, it looks really bad, but it's 1 plus x squared over 95 times 130 square root positive minus 9. And then the other one is minus square root and that, and then minus 9, but that one's negative. So it is possible. Probably not worth it.
Oh, yeah, I see the graph now.
There you are. Well, that's cool.
Yeah. Yeah, it just seems like too much work to do it on test.
Yeah, I mean, if you had a lot of extra time, you might consider doing that.
Mm-hmm.
All right, on to number 15.
How many questions did I send you?
I see 14, 16, 2, 4. That's it.
Oh, well, the rest of them are, there's like 17 through 26, and they're basically the same thing, except they give you like the conjugate accesses to, oh, well, yeah, they're actually all the same thing. Never mind.
Yeah, I don't have any of those, but if you want to send them over, yeah, I'm happy to look at them, help you with.
Oh, I thought they were different, but they're pretty much all the same.
Yeah, I mean, there you've got to we've done 3 lessons, parabolas, ellipses, now hyperbolas. Like you're seeing that I'm showing you they're the same. You find the table values, you graph in a certain order, or you go backwards in a certain order. So
Yeah.
so some good practice here on this. One thing you notice here is that the K is the same in the foci. In the previous problem, the H was the same. That tells you which one it is also. If you look at your equations, I'll snip this in again. Really important to have the equations down. Can't overemphasize that enough. But when you've got the equations here, your foci equations, one H is the same, one is K in the same in both. So that's why we're in the horizontal transverse axis. Is that clear?
Yeah.
How you'd figure that out? All right. So then you go right to the foci equations. You know that K is 4. But this time you're focusing on the H plus minus A. It's H plus A is the positive one, 8 plus 7 square root of 2, or the bigger one, I should say. H minus A equals 8 minus 7 square root of 2. So in the previous problem, we did like K plus A, K minus A. I'm sorry, I'm looking in the wrong place. Foci. So this just changes to a C. Sorry about that. Foci, not vertices. They could give you the vertices, but they're not. So now you add up the equations. 2H equals 16. Isn't that nice? That went away. H ends up being 8. So we're well on our way. We now just need to find A, B, and C. To find C, you use one equation or the other. We'll just use the top one. 8 plus C equals 8 plus 7 square root of 2. Subtract 8 from both sides, and you get C equals 7 square root of 2. I'm always going back and filling in that table. All right, so from there, we need to find A or B. We remember from the previous problem, the conjugate axis is 2b. 2b equals 14, so b equals 7. To find the other value in that ABC group, you use the Pythagorean theorem, a squared plus b squared equals c squared. Notice again, it applies to both the right and the left. A squared plus 7 squared equals 7 square root of 2 squared. Seven square root 2 squared is 98. And then you move the 49 over and you find that A is 7. Okay. So we've got the five values, H is 8, K is 4. Once you have those, you can write the equation. You've got to know which transverse axis it is, but we've already decided that. So you're just putting those numbers in here. X minus 8 squared over 7 squared minus y minus 4 squared over 7 squared equals 1. X minus 8 squared over 49 minus y minus 4 squared over 49 equals 1.
He said he'd give us a note card for the test.
Ask him if you can take that reference sheet in instead. Be a lot easier.
This reference sheet is the last quizzes were open note, so this was it was kind of crazy having it because I just kind of had everything right there.
Yeah, I mean, beg, plead, say please. I'm a graduating senior. I just had ditch day. Yeah, I don't know. Bring him a coffee. Do something. It really will make a difference to have this. You're not going to see this ever again. You really, you don't. It's not like you're going to see this in. You might see it like if you end up taking a pre-calc trig at Pima or U of A, might. But it's dicey. You're not. This is teachers don't like teaching us.
It's not that bad. It's kind of annoying, but it's not like what we did like a month or two ago, where it's just like impossible.
Right. These all can be done. You can work your way through all of them. No guessing. Okay. I mean, 14, 16, we can do as much as we can. Where do you want us to go next?
14's a bit different.
All right, let's do 14. So notice in 14 that the X value is the same in both. That's the H. That tells you the axis again. Since H is the same in both, it's the vertical transverse. Okay, so that's everything on the that's the left equation here. So we've got to find HK, A, B, and C. And we have found H. H is 5. Here's K, A, B, and C. To find A, B, and C, one of those we're going to get from the foci equation. So the foci equation says K plus C and K minus C. And then sometimes like, well, which one is it that goes in the top? Which one that goes in the bottom? You kind of got to look at the signs here. See how these ones on the right are both negative? That's going to be the one, the smaller one. Since this one's positive and this one's negative, it's going to be slightly larger. So you're writing 2 squared 34 minus 15 over 2. 2 squared 34 minus 15 divided by 2. This is just an exercise in algebra. This is not difficult to do. but it is kind of a, you know, worst case algebra scenario. So that it's 2k on the left. On the right, you have 2 squared root 34 over 2 minus 15 over 2. That's the top. And then you're adding negative 2 squared root of 34 over 2 minus 15 over 2 on the right. So notice that the roots always cancel, always. Don't have to think of any exceptions to that. And then this 2k equals minus 30 over 2, which is really minus 15. So k is minus 15 divided by 2. Not great, but it is okay. To find c, you go back to either equation. We'll go back to the first one, k plus c. K is really minus 15 over 2 plus c equals 2 squared root 34 over 2 minus 15 over 2. If you do enough of these, you realize that c is always the other part of it when there's roots involved. So just the square root of 34. And then we're given that 2b is 10. So b is 5. Pythagorean theorem, you find that c is, or a is 3 using Pythagorean theorem. All right, we do unfortunately have to stop there for today. I'm sure you're very disappointed to have to keep doing conic sections, but